been 11 days or so since we've had class, so let's do a little bit of review. Our last class before we started spring break, we were talking about different methods of dosage calculations. And we discussed three methods. And as I had mentioned last class, I went through them kind of in reverse order of my preference of using them. The first one we covered was the formula. You recall that formula was the doctor's orders divided by the on-hand dose times the vehicle equals the amount administered to the patient. And the advantage, of course, of this, the strength of this, is that it's very straightforward. You just plug the numbers in and calculate and you get the result. As long as you know what each of those letters mean. D, H, V, and A. If you understand what they mean and how to get them out of the information, very quick, straightforward, not a lot of options for that. But that's also part of the weakness of it. It only applies to certain situations. And of course, the specific situations we'll say here. And we saw that in a couple of situations, it might have to be applied more than once. So multiple applications for complicated problems. And also, it only applies to those straightforward single dose applications. So it can't be used for IV flow rates, any sort of weight-based calculations or anything like that. The second method we talked about was the proportion method. In the proportion method, its strength was that we didn't have to memorize a formula. All we had to do was match up units. So if we looked at our proportion, it didn't matter whether we did the doctor's orders and the on-hand dose together. All that mattered was that those two had the same units. So whatever goes on top has to have the same units from one side to the other. And then on bottom, the same thing. So we're looking at the amount to administer goes under the doctor and the vehicle goes under the on-hand. Again, those two had to have the same units. But it didn't necessarily have to be in that specific order. We could have rearranged it. It could have been D over H equals A over V. As long as now it would be matching up the units here, those two would be the same and those two would be the same. So the strength of the proportion was that all we had to do was match up units. We didn't have to memorize where things went. We just had to know what information in the problem was useful and match up the correct units. Of course, its weakness was the same as the weakness for the formula. It only applies in simple applications. If we have a more complex situation, we either have to apply the proportion more than once, or we have to memorize a new procedure for it. And then we ended up with dimensional analysis. And I, of course, showed a little bit of a bias towards dimensional analysis because its strength is, again, no formula to memorize. In fact, all you have to do is be able to match up the units. All you're going to do is let the units dictate the calculation. Even if you don't even know what the unit means, the units dictate the calculation. So like the actual term units is a unit of measurement for some medications, whether it's an international unit or just a standard unit. most of us don't know what an international unit is, and actually it's slightly different depending on what the vitamin being measured is. But it doesn't matter as long as we know what the equivalency of that international unit is to our other units. We can still use it in the calculation and we just match everything up. The other big strength of the dimensional analysis is it applies in all situations. So that means that we can use it for IV flow rates. We can use it for dosages based on weight, dosages based on body surface area. I'm going to use it for safe dose calculations. It can literally do anything without having to memorize a bunch of new formulas. If we're going to use the dosage calculation formula, which is what a lot of students do resort to when they're in the beginning stages because it is straightforward, but then we'd have to memorize a new formula for dosages based on weight, a new formula for IV flow rates, a new formula for dosages based on body surface area, and even some new formulas for safe dosage calculations as we go through. I'm not a big person on memorizing formulas, so that's why I tend to go towards the dimensional analysis. So with that said, as we do our examples here over the next several classes, I am going to tend to resort to, well, I'm not going to tend to, I will do the dimensional analysis calculation first. But if there are any of these problems that you would like to see done with one of the other methods, please feel free to stop me and ask me, could you go through that with either the formula or the proportion method? I'd be more than happy to do that for you. So the purpose of the day is I want to do several examples so we can get used to using dimensional analysis and breaking down these problems, looking at what the information means, what is useful, and then just setting them up and doing some calculations. So we're going to start off with a pretty simple calculation. Remember, we're given the doctor's order. And let's say in this case, it's for 750 milligrams of ibuprofen. My handwriting's really bad today. Sorry about that. Q6H. Now remember the Q6H, that was one of those abbreviations we talked about the week before spring break. That is in your book on page 150. It really doesn't do much in this problem because we're just looking at calculating a single dosage. All that means is whatever dosage we calculate has to be administered to the patient every 6 hours. It becomes way more important when we look at IV flow rates or when we look at safe dosages later on in the course. Safe dosages are often dictated as an amount per 24 hours, or they might be given in a different time window. If the safe dosage is given as an amount every 8 hours and the order is every 6 hours, we have to adjust those dosages so that we can compare to make sure that we're not overdosing a patient. Then, of course, in this case, our supply is 500 milligram tablets. Now, remember, I'm actually going to add the word in here for tablets. I'm going to add the word scored tablets. We had mentioned this briefly before spring break. A scored tablet, if we're looking at a tablet, the scored tablet is just one that has a line across it on both sides. And what that line is for is to make it easier to break the tablet in half. You would still use a pill cutter in most cases to break it in half. But with a scored tablet, we're going to round to the nearest half tablet. We'll look at that process in a little bit. So for this problem, let's go ahead and break it down. Remember, for dimensional analysis, we always start with the doctor's orders, 750 milligrams. In this case, the time factor, again, it's a single dose every 6 hours. It's not a dosage given over time like an IV. So the time factor doesn't come into this. So we're just going to put the 750 milligrams over 1. Now the 500 milligram scored tablets, remember that is actually an equivalency. What that is telling us is that 500 milligrams is equivalent to 1 tablet. So in this next step, I want to get rid of milligrams. So I'll put milligrams on bottom so that they'll cancel out when we multiply our fractions. That's 500 milligrams equivalent to 1 tablet. So now the milligrams will cross cancel out in our calculation. The only unit we have left is tablets. And that's what we're looking for. How many of these tablets do we administer to the patient? So now it's just a matter of doing the calculation. On top, 750 times 1 tablet is 750 tablets. Now that number seems extreme, and it is. It's kind of a nonsense number at this point until we finish our calculation. On bottom, 1 times 500 is 500. And now we go ahead and divide out. 750 tablets divided by 500 is 1.5 tablets. So we would administer 1.5 tablets to that patient. Now I said that, for scored tablets, we round to a half tablet. This calculation came out to be a half tablet. Let's look at an example where it does not. So let's say our order is for 500 milligrams of acetaminophen. And our supply is 300 milligram scored tablets. So this calculation, pretty simple. Doctor's order is 500 milligrams. Put that over 1. And then once again, the 300 milligram scored tablets is saying 300 milligrams is equivalent to 1 tablet. Well, I want to get rid of milligrams, so I'll put milligrams on bottom in my next fraction. Tablets, of course, are going to go on top. 300 milligrams, I should say, equals 1 tablet. So the milligrams cancel out, and right now our only units left is tablets, which is what we want. So we'll multiply. On top, 500 times 1 tablet is 500 tablets. On bottom, 1 times 300 is 300. And we divide this out. 500 tablets divided by 300 is 1.67 tablets. Or if you want to leave it as a fraction, that's 1 2/3 tablets. So if we need to round that to the nearest half a tablet, if you recall from the first week of class, we talked about rounding as being on a number line. And so if we're rounding to the nearest tablet, the number line would be labeled to 1s. But we're not rounding to the nearest tablet, we're rounding to the nearest half tablet. So our number line is numbered in halves. And of course, I place 1.67 or 1 2/3 on it. It's going to fall somewhere in here. So the closest half to that is 1.5. So what we would administer to our patient here is 1.5 tablets. Now it sounds awkward to say that we're going to take 1.67 or 1 2/3 and round it down. We're so used to 1.67 would be rounded up normally if we're going to the nearest whole number. But we're not going to the nearest whole number, we're going to a half. Rounding to a fraction is always a little bit awkward for those numbers in the center of the number line. But anything more than 1 1/4 and anything less than 1 3/4 is going to get rounded into that 1.5 in the middle. Okay, let's look at an example of a fluid medication. So let's say we have an order is for 80 milligrams of elixir. Elixir just means it's a liquid medication. Our supply is saying 16 milligrams in 5 milliliters. So again, this is just saying that this is a liquid medication, certain concentration, certain amount of medication in each volume of liquid. So once again, we'll start out with the orders, 80 milligrams. So I put 80 milligrams over 1. Now remember, whatever goes in this second fraction, milligrams have to go on bottom so that the milligrams cancel out. This label is saying that 16 milligrams is equivalent to 5 milliliters of fluid. So that's what goes in this fraction, 16 milligrams on bottom, 5 milliliters on top. And so the milligrams cancel out, and we're going to be left with milliliters. Since this is a liquid medication, we are going to measure it out in milliliters to administer it to the patient. So that is what we want, is milliliters for our unit. So on top now we have 80 times 5 milliliters, which is 400 milliliters. On bottom we have 1 times 16, and then we divide. So we'll do 400 milliliters divided by 16 is 25 milliliters. So we would administer 25 milliliters to the patient. Well, enough with the really simple examples. Let's look at something maybe a little bit more complex, not horribly, but let's look at an order for Axid. Let's go 0.3 grams POBID. So again, some interpretation here. PO just means by mouth, orally. BID means twice a day. Neither one of those really affect this calculation. Orally could be a tablet or a capsule, or it could be a liquid medication. So it really doesn't narrow down what our types of medications are. So let's look at the supply. So let's say our supply here is a bottle containing 60 capsules of Axid, of course, at 150 milligrams per capsule. So here's an example where we have some unneeded information. The fact that our bottle contains 60 capsules of Axid just means that we have a total of 60 capsules that we can administer over time. Has nothing to do with the calculation of how much to give to this patient on each individual administration. It does tell us, if we're going to look at a long-term medication of a patient, how long we'd be able to go before we'd have to get a new bottle. That's really all it tells us. Again, nothing to do with the calculation. So we'll start with the doctor's order here, 0.3 grams, and we'll put that over 1. Now in our next calculation, our next fraction here, we need grams on bottom. But there is nothing in this problem that has grams in it. We do have milligrams, however. So to get from grams to milligrams, this is just one of our simple measurement conversions. So we look at this and we look at which unit is larger, a milligram or a gram. And of course, a gram is larger. The gram is the main unit. The milligram is one of those smaller fractional units. And then we look at, so we put the 1 with the gram, the larger unit. Then we look at how many milligrams are in a gram. This is one that should become fairly reflexive for you over time. There's 1,000 milligrams in 1 gram. Now the grams have canceled out. We are now currently in milligrams. Well, that is not what we want for our final answer. We have more work to do. So we're going to get rid of milligrams here by putting it on bottom so that cancels out. And then we see 150 milligrams per capsule. So again, that is saying that 150 milligrams is equivalent to 1 capsule. Now I should note here, because these are capsules, not tablets, a capsule cannot be divided. A capsule is filled, it's the little gel caps that are filled with the medication inside of them. The capsules either have to be filled to the correct amount of medication or an even fraction of the medication so that you can administer a whole number of capsules to the patient to get the desired dosage. If that's not the case, then you do have to go to a pharmacist and have them redivide some of the capsules for you. Let's see if we need that in this case. So the milligrams will cancel out. Our units, only unit we have left is capsules, which is what we will administer to the patient. So that's what we want. So now on top, we have 0.3 times 1,000, which is 300, times 1 capsule is 300 capsules. On bottom, 1 times 1 times 150 is 150. And we go ahead and divide that out. 300 capsules divided by 150 is just 2 capsules. So that did come out to a whole number of capsules, so we don't have to worry about going to a pharmacist to have a capsule divided to get the correct medication there. So we're good. Now again, this one had an extra step in it because we had to convert from grams to milligrams. Dimensional analysis allowed us to do that right within the calculation, all in one long chain, rather than having to go through the dosage calculation formula a second time, or having to do that conversion first and then running it through the formula. Our next example, let's look at an order for Amoxil. 0.375 grams PO-Q8H. So again, PO just means orally, Q8H means every 8 hours. This is a single dosage calculation, so neither one of those mean anything to us at this point. The Q8H would just mean if we're looking at a safe dosage over time, that would come into play, but at this point we're not using that as our calculation. So let's look at our supply. So in our supply, we have an 80 milliliter bottle. It says to reconstitute Amoxil oral suspension at 150 milligrams per capsule. Or sorry, 150 milligrams. I'm reading from the wrong problem. Oral suspension at 125 milligrams in 6 milliliters. So there's a couple of things here. First, 80 milligram bottle. That is useless information. All that is, or 80 milliliter bottle, all that is telling us is the total volume of the bottle. It doesn't play a part in our calculation here. It might in the end tell us if we need to get a second bottle to get the appropriate dosage, or how many of these doses we can get out of a bottle. But for the immediate calculation, it doesn't do anything for us. Reconstitute, that just means, remember we discussed 2 weeks ago that a lot of medications are shipped dry. So even though they're going to be administered as a liquid medication, they come in a bottle with just dry powder in the bottom, or a concentrated syrup, elixir in the bottom of them. And then we add sterile water or saline to those bottles to reconstitute the medication. This is because shipping, when you're shipping stuff, weight is usually the financial factor. It costs more to ship heavy things. So if we can avoid having the water in there when we ship them, it makes it cheaper to ship those materials. The second factor, we mentioned, it makes them more durable. Once the water, a powder will keep for a long time. Very little risk of molding as long as it's dry. And these are vacuum sealed bottles, so there's no reason to expect moisture to get in there. No risk of molding, spoilage, any of those other things. Also, a lot of shipping is done not in temperature controlled or climate controlled environments. So this time of year, you're shipping medication. If it has a lot of water in it, there's a risk of that freezing. And freezing can, first of all, threaten the integrity of the medication, or it can just plain burst the bottle. I mean, we've all left a water bottle or something in a car and come back and it's split open or the lid is blown off. I know I've had to scrub some sticky junk out of the console of my car a couple of times because I screwed up and left something in there overnight when it was too cold. So reconstituting this is just saying that it was shipped dry so that we didn't have to worry about any of those factors, and then water is added to it later. So either we have to add the water to it before we use it, or it's already been added. Either way, the only important piece of information on that label is this right here, that it is constituted to 125 milligrams per 6 milliliters of fluid. So we'll start out with the doctor's orders again, 0.375 grams. So again, the units become very important because we have grams there, and we want to get rid of the grams. So we have to put grams on bottom. that there's nothing else in this problem that has grams in it. But we do have milligrams there on our label. So we have to change the grams to milligrams. So again, this is a standard measurement conversion. 1 gram is 1,000 milligrams. So the grams have canceled out. We're now in milligrams as our unit, which is not what we want, but it allows us to use this equivalency then. We'll put milligrams on bottom to cancel it out. That's 125 milligrams in 6 milliliters. Now the milligrams cancel out. The only unit we have left is milliliters, which, since this is a fluid medication, that's what we want to administer to our patient. So on top there, we have 0.375 times 1,000, giving us 375, times 6 gives us 2,250. And the only units on top is milliliters. On bottom, there are no units, so 1 times 125 is just 125. So then we have to divide that out. 2250 divided by 125 is 18. So that's telling us that we are going to administer 18 in the units that are milliliters of that medication to the patient. Well, let's look at one that has options. So our order here is for codeine, GRSS, POQ4H, PRN, pain. So here there's a lot of information here. The pain just means that it's administered for pain, just the purpose of the medication. PRN is as needed, but the Q4H means no more than every 4 hours. You can give the medication every 4 hours if it's needed. If it's not needed, you can extend the time out longer than that. PO means orally, so this is probably going to be some sort of a, for codeine, it's usually going to be a tablet, but it's either going to be a tablet or an elixir. Now, the important stuff. GR means grain. Remember, that's a unit of measure. SS is our Roman numerals. When we talk about using grains for a medication, we typically use Roman numerals. And when we use Roman numerals, the unit typically comes before the number, like this, the grains and then the SS. SS, if you remember, stood for 1/2. So what this order really is it's saying 1/2 of a grain of codeine. And then let's look at our supply. In our supply, we have 2 options. Option 1 is we have 15 milligram tablets. I'm not writing the word scored, but whenever I say tablets, it's implied that it is a scored tablet, that we can go to a 1/2 a tablet. Option 2 is 60 milligram tablets. So let's start out with our doctor's order here. The doctor's order is 1/2 of a grain. I typically write out the whole word grain just because if I use GR, a lot of people confuse that with gram, and that is nowhere near the same. So it's a huge mistake to do that. So make sure I write out the word grain just to avoid that possibility of that error. Now I need to put grains on bottom here because I need to get rid of grains. However, nothing else in the problem has grains in it. So we need to figure out, we need to get grains to a unit that we can use. Well, both options have milligrams in it, so I want to take grains to milligrams. If we look at this equivalency, we know that 1 grain, or if we have it memorized, maybe, 1 grain is 60 milligrams. So 1 grain, 60 milligrams. So here the grains will cancel out. We're now in milligrams. Now milligrams is not our final answer, but it is what we have available in our on-hand dose. Now, since we have options, what I'm going to do is I'm going to do the calculation at this point and then apply the options to it after that. So here I have 1/2 times 60 milligrams, which is 30 milligrams. On bottom, 1 times 1 is 1. So we need this dosage of 1/2 of a grain is the same as saying 30 milligrams of the medication to administer. So now let's look at that 30 milligrams as our dosage, as our ordered dose, and see what that would do with each option. So for option 1, option 1 was 15 milligrams per 1 tablet. So milligrams cancel out. 30 times 1 tablet is 30 tablets. 1 times 15 is 15. That divides out to be 2 tablets. That is not a horrible option. Option 2, well, we still need to give 30 milligrams, but option 2 was 60 milligrams per 1 tablet. So the milligrams still go on bottom so that they cancel out. Tablets still go on top, just the amounts are different. So on top, 30 times 1 tablet is still 30 tablets. On bottom now it's 1 times 60 is 60. That divides out, 30 divided by 60 is 0.5 or 1/2 of a tablet. So we have a choice. We either give 2 of the 15 milligram tablets or 1/2 of the 60 milligram tablets. Codeine is a little bit more of a sensitive medication as a pain medication. So it would probably be more precise to give 2 of the 15 milligram tablets, just because when you split a tablet, even if you use a pill cutter, it's not always perfect right down the middle. One side usually gets slightly larger than the other. So I would say better to go with the 2 smaller tablets, but either of those dosages would be correct. Okay, next example. We're going to have an order for Synthroid, 0.125 milligrams, PO daily. So the daily there just means once a day, PO means orally. Our supply, bottle of 100 scored tablets. Again, the only useful information there is scored at 50 micrograms per tablet. So it's really the 50 micrograms per tablet that helps us. The score tells us we can round to the nearest 1/2 a tablet if needed. So we start out with the doctor's orders. 0.125 milligrams, put that over 1. Now we need to get rid of milligrams. We'll put them on bottom. But once again, there's no milligrams anywhere else in this problem. But we do have micrograms. So we're going to have to make the conversion from milligrams to micrograms. Milligrams is the larger unit, so I'll put 1 with milligrams. And if you look at our metric conversion charts, there's 1,000 micrograms in 1 milligram. So the milligrams cancel out. So now we're in micrograms. So now we can use our equivalency from our bottle, saying micrograms, there's 50 micrograms in 1 tablet. And so the micrograms cancel out. We're now in tablets, which is what we want to administer to our patient. So that's what we want our final unit to be. So on top, we have 0.125 times 1,000, which is 125, times 1 tablet, so that's going to be 125 tablets. On bottom, 1 times 1 times 50 is 50. 125 tablets divided by 50 is 2.5 tablets. So again, we have to round this to the nearest 1/2 a tablet. 2.5 is on a 1/2 tablet. So that's 2 1/2 tablets that we're going to administer to the patient. Let's have an order for potassium chloride. $40 milliequivalents PO, BID. Again, PO is orally, BID means bi-daily, twice a day. Potassium chloride is used for, it's an electrolyte for equalizing out the body in many cases. So supply, we're looking at a vial of 15 milliliters of oral solution. Constitute 20 milliequivalents per 15 milliliters. So here's a case where, first of all, we don't even know what the unit milliequivalent means. But we have milliequivalents, 20 milliequivalents and 15 milliliters. We have its equivalency to another unit. That's all we need to convert it to something that we can administer. Now there's a word that came up here, solution, and a word that came up before that was suspension. Suspension, when we see that word, that means that we must shake the bottle or mix the medication before we administer it. A solution means that it's dissolved together and it will stay that way unless it either has, if it's too cold or too hot and falls out of solution, or if something happens to it, it's still a good idea to shake the bottle. But for a suspension, you must shake the bottle, must remix that mixture, or because in a suspension, it only stays in there for a certain amount of time. Over time, the heavier part, the medication, falls to the bottom of the vial. So when you see the word suspension, you have to be very careful to make sure you shake it thoroughly. When we're looking at a solution, it's not as important. So not a bad idea to mix it, but it's not required. So let's start with the doctor's orders. 40 milliequivalents. Well, an equivalent is a unit of measure. A milliequivalent is a thousandth of an equivalent, just like a milligram is a thousandth of a gram. Next, this is telling us we have to get rid of the milliequivalents. So it's going to, MEQ is going on bottom. And it says 20 milliequivalents in 15 milliliters. So remember, that is a measurement equivalency. So we can use that in our conversion factor. The milliequivalents cancel out. And we're in milliliters, which is what we will administer to our patient. So 40 times 15 is 600 milliliters. Over 20. We divide that out. 600 milliliters divided by 20 is 30 milliliters. So we would administer 30 milliliters to the patient. So here's one spot where this extra information does come into play. It was a 15 milliliter vial. We need 30 milliliters for the patient. So we're going to have to make sure that we have at least 2 vials on hand to make sure that we have enough to administer to that patient. Let's look at an order for penicillin. Let's do 1,200,000 units. IM. Penicillin, IM stands for intramuscularly, so penicillin is usually injected into the muscle. Now, once again, we don't know what a unit is, but as long as we have some sort of equivalency, it doesn't matter. So our supply on the bottle, it says that this medication is 100,000 units per 5 milligrams. So again, that's an equivalency. That is saying that 100,000 units is equal to or equivalent to 5 milligrams. Also on the bottle, it then says that it's constituted at 15 milligrams in 4 milliliters. So we'll start out with the doctor's orders. 1.2 million, 1,200,000 units over what? Units can be abbreviated with just a capital U. I tend to write out the whole word again just because the capital U can get confusing to people. So we're getting rid of units, so I'll put it on bottom. We have this equivalency, says 100,000 units in 5 milligrams. Now the units have canceled out. We are in milligrams, not where we want to be, so we have to keep going. We got to get rid of the milligrams, putting that on bottom. 15 milligrams in 4 milliliters. So we write that in. So the 15 milligrams cancels out. Now our unit is milliliters. That's what we want. That's something we will administer to the patient. So on top, we have 1,200,000 times 5, which is 6 million, times 4, which is 24 million. The only unit left on top is milliliters. On bottom, we just have 1 times 100,000 times 15. So that's 1,500,000. And we divide that out. That comes out to be 16 milliliters, I believe, when we divide that out. 24 million divided by 1,500,000. Yeah, that's 16 milliliters. So there's what we're going to administer to that patient. So again, here's a case where we don't even know what the unit means. The word units is our unit here. And we don't even really know what size that is or what that means. But because the label tells us how that relates to one of our other known units, we can go ahead and do the calculation without even really having to understand what the units represent there. Let's look at an order for astrophene sulfate. GR 1/300. So again, GR is grain, 1/300 is literally 1/300 of a grain. Let's look at our supply. Our supply here is astrophene sulfate solution, where it is 2 milligrams in 5 milliliters. So we'll start with a doctor's order, which is 1/300 of a grain over 1. Now, we don't have grains anywhere else in our information here, but we do still have to get rid of grains. But we have milligrams. And remember, we said before, if we look it up, 1 grain is 60 milligrams. So the grains will cancel out. Next, we have to get rid of the milligrams because we need to administer this to the patient. It's a solution, so we need to get it into a liquid form. How many volume of liquid? So milligrams on bottom. And this says 2 milligrams in 5 milliliters. The 5 milliliters goes on top. Milligrams cancel out. On top, now we have 1/30 times 60 times 5, which is just 1 milliliter. On bottom, 1 times 1 times 2 is 2. So that is 0.5 milliliters that we would administer to the patient. So with that kind of brings us back up to where we were before spring break. What I'm going to give you is just actually the homework on constituting solutions. Page 172 through 173, 1 through 9, the odd. It's just a little work on reconstituting solutions, adding the liquid into it for the dry mixture. I assigned this one before spring break, but if you want to go back and review some of the dosage calculations, that would be back page 162 through 163. If you want to look back on those to see if you can do some of the calculations we did today on our own. I'm going forward Wednesday and Friday. We're going to keep doing some more examples. I'm going to try to have time. I didn't have a lot of time today because we're running up on the clock. To give you at least a couple of those to work on in your notes, and then we'll double check them together to see if you are picking up on it. So with that, you guys have a great day. Hopefully we'll see you all on Wednesday.